Good morning, everyone. Today we're diving into one of the most critical areas in airline engineering supply chains: inventory management and optimization. Why is inventory so important? Imagine your airline's entire operation relies on thousands of parts, from tiny bolts to complex avionics units. If you don't have the right parts when you need them, planes can't fly. Delays cost money, lots of it, and impact customer trust. But holding too much inventory also drains resources. Excess parts sit unused, get obsolete, or require costly storage. So inventory management is a delicate balance between availability and cost. Real-life example. British Airways once faced a $5 million loss due to multiple aircraft on-ground incidents triggered by stockouts during a fleet transition. This highlighted how critical accurate inventory management is to operational continuity. Today, we'll explore how airlines classify inventory, measure its performance, and optimize holdings to achieve that balance. Inventory in airline engineering generally falls into three categories. Rotables. These are parts designed to be repaired and reused multiple times. For instance, Delta Airlines uses a rotating pool of landing gear assemblies shared across its hubs. This pooling reduces the total number of units needed while maintaining availability. Repairables. Parts that are sent out for repair rather than replaced outright. Hydraulic pumps often fall into this category. Repairables allow airlines to save on costs by refurbishing parts rather than buying new ones. Southwest Airlines contracts external MRO providers to manage their repairables program efficiently, which lowers capital tied up in spares. Expendables. Consumables like nuts, bolts, seals, and filters that are used once or have a limited lifespan. Managing expendables effectively prevents waste. EasyJet, for example, uses predictive analytics on historical consumption data to time replenishment of expendables precisely, reducing excess stock. Critical spares. Parts identified as critical due to their impact on aircraft operations if unavailable. Qatar Airways maintains higher safety stock levels for certain critical APU components to avoid AOG events. Real-world incident. Emirates Airlines experienced an AOG incident because a single avionics card was missing. This card wasn't classified as critical at the time, causing a costly delay and operational disruption. This underscores the importance of accurate classification. How do airlines measure the effectiveness of their inventory management? Key performance indicators or KPIs provide visibility. Fill rate. This is the percentage of demand that can be met immediately from available inventory. Lufthansa targets a 98% fill rate for rotables, ensuring that the majority of demands are fulfilled instantly without delays. Stockouts, the frequency and duration of stockouts. Every stockout risks an AOG event. For example, a missing part once grounded 4 aircraft for 12 hours at a mid-sized carrier, leading to a $200,000 loss just in operational disruption. AOG responsiveness. How fast the supply chain responds to urgent AOG demands. Qantas has a rapid response logistics team that aims for parts delivery within 3 hours domestically, minimizing aircraft downtime. Inventory turnover. How often the inventory is used and replenished annually. Ryanair aggressively manages turnover, reducing holding costs by 15% while maintaining high availability. Obsolescence rate. The percentage of inventory that becomes obsolete due to fleet changes or technology updates. United Airlines reduced obsolete parts by aligning inventory purchases with fleet retirement schedules. Modern analytics tools allow airlines to track these KPIs in near real time, enabling proactive inventory decisions. Optimizing inventory holdings is about balancing cost and availability. Min-max levels. Setting minimum and maximum stock thresholds based on consumption rates and supplier lead times. Alaska Airlines automated min-max replenishment, reducing stockouts by 20%. Safety stock for critical components. This buffer stock protects against demand variability or supplier delays. Cathay Pacific increases safety stock of parts with seasonal failure spikes, especially during winter when weather impacts operations. Fleet standardization. Standardizing the fleet reduces the diversity of spare parts needed. Southwest Airlines operates a single aircraft type, the Boeing 737, simplifying inventory significantly. Inventory pooling. sharing parts inventory across multiple hubs or airline partners. Star Alliance members pool rotables to reduce capital tied up in spares, while improving parts availability network-wide. Technology. Predictive analytics and AI help forecast failures and optimize stock levels. Lufthansa Technik uses digital platforms to predict part failures and adjust inventory preemptively. Challenges. Balancing cost versus availability is tricky. Overly lean inventory risks operational disruption, while excessive inventory inflates costs and risks obsolescence. Example: Ryanair's lean inventory during rapid fleet growth saved millions but required exceptional logistics and demand forecasting to avoid AOGs. Let's apply what we've learned. Scenario: your airline just inducted 20 new aircraft types with diverse parts and lead times. How would you approach? Classifying inventory, setting safety stock, managing critical spares across hubs, minimizing obsolescence risk. Inventory management in airline engineering is a continuous balancing act. Classify parts carefully, track performance with KPIs, and optimize holdings using smart strategies and technologies. This ensures operational reliability without bloated costs.